Hello and welcome everyone to the CyVerse webinar series. I'm Tina Lee, CyVerse's User Engagement Officer. Today's webinar is how to get the lay of the land using the Terrain Application Programming Interface, otherwise known as an API, for programmatic access to CyVerse's backend services, presented by Sarah Roberts. For those of you who are new to CyVerse, we are a cyber infrastructure project funded by the U.S. National Science Foundation, and we offer these free webinars to fulfill a key part of our mission, which is to train scientists like you on how to use CyVerse and its computational resources. A bit of housekeeping first before we start the webinar. Sarah's presentation is about 30 minutes. She may go a tad longer. Please mute your audio and stop screen sharing if you have it on. But please do open your chat window where you can type questions for Sarah to answer after her presentation. This webinar will be recorded and we will send you the link for that via our email to you for viewing probably Monday at the latest, and you can review that at any time. CyVerse offers other virtual training events besides these webinars, and all of our learning materials are online. So be sure to visit our Learning Center pages for more learning and teaching resources. I also want to highlight an upcoming remote workshop in November taught jointly by CyVerse and NEON, which stands for the National Ecological Observation Network, on using and analyzing remote sensing data generated by NEON's airborne observation platform. So head to our website to register and for more information on that workshop. And now I'm pleased to introduce Sarah Roberts, CyVerse's Senior Software Engineer. Sarah joined CyVerse in 2010 as a key member of the core software team and was instrumental in engineering the discovery environment's backend microservices, authentication, and jobs. More recently, she was an invaluable contributor to the installation of CyVerse Austria by Graz University of Technology last year. And when she's not writing code or fixing bugs, Sarah plays guitar with her band and is known far and wide for the best and hottest fresh salsa in the universe. Hello, Sarah.
Hi, Tina. Thanks for the intro.
Okay.
First, I wanted to make a quick disclaimer. I know that my biotext said that I wrote the initial code for Terrain. This is technically true, but that was such a small kernel of what Terrain has become. I cannot claim sole authorship. I can barely claim initial authorship at this point. We have an entire team of software engineers working on it, and credit goes to the entire team. So with that, I'm going to share my screen. Hopefully everybody can see it now. Okay, for today's presentation, I'm going to be using the a GitHub repository called Terrain Notebook. This repository has two Jupyter notebooks that we use to provide an introduction to Terrain. And I'm going to be using this notebook, terrainautomation.ipynb. If you want to go to this repo and follow along, you're welcome to do so. You will need Vice access in order to run the notebook, at least using this link here. And if you want to follow along, feel free to click on this link. That will open up a copy of the notebook in the discovery environment using our Vice feature. And you'll have to have access to Vice in order to use it. So if you don't have that, you can feel free to request it. We'll grant it to you, and you can go through this later on your own if you like. Here's the URL to this repository. It's https://github.com CyVerse Terrain Notebook. And there's some links to some documentation here. We've got the interactive console here, and we've got the legacy API documentation, which is our older set of documentation. The interactive console is not yet complete, so you might have to go here if you encounter an endpoint that you want to use that isn't documented in the interactive console yet. So I already have a copy of this Jupyter Notebook in the oven, and I need to get my Zoom window out of the way here so I can actually click the tab. Okay, there we go. Okay, so the target audience for this presentation is consists of users who are interested in automating tasks using the discovery environment, users who want to integrate their web application with CyVerse, and also users looking for an introduction to APIs just in order to make use of other APIs either related to CyVerse or outside of CyVerse. Because of time constraints, I'm going to assume that you're a little bit familiar with Python and JavaScript object notation. If you want some introduction, I didn't provide the link to Python, but that's python.org. You can go to that URL and find documentation there. And then there's a link here for JavaScript object notation that just goes to Wikipedia, but the page is pretty good. I do want to show you an example web app that is integrated with the discovery environment. The Integrated Genome Browser, which is a desktop application built by Lorraine Lab at UNC Charlotte, has an associated web application called Bioviz Connect. I'm going to go to this. I'm going to pull this up first, so I'm going to have to increase the font size as soon as it comes up here. Okay, as you can see, I'm already logged in. And this is actually looking at data in my home directory in the CyVerse data store. So this is one example. This is open source, so you can go look at their code if you would like. And there's an introductory video here, and you'll probably want to open up the notebook in order to go to that link if you want to look at it. I'm not going to pull it up right now just because the link will be hard to type anyway. Okay, so some of you might be asking, well, what is a web application programming interface anyway? An application programming interface is essentially just a way for two pieces of software to communicate with each other. They're common in operating systems and programming languages and software libraries. For locally running libraries, it usually just consists of a set of functions that you can call. A web API is a little bit different in that the software you're interacting with is running on a remote server somewhere on the internet. Usually they use internet protocols such as HTTP or SOAP to send data back and forth. Terrain uses JavaScript object notation to transfer the data, and it does use the HTTP protocol to make requests. You will see these types of APIs called REST APIs or RESTful APIs. We don't claim to adhere to all of the tenets of REST architecture, but we do try to adhere most of them. Now with this, you might be wondering, well, I have the discovery environment, so why bother to use Terrain if I don't have to? And that is a very good question, because the DE provides a lot of tools to interact with the discovery environment, to interact with CyVerse resources, and also to launch jobs or manage your data or whatever you need to do. So a lot of times you don't really need to use an API, but there are some circumstances where Terrain can provide you with the tools you need to do your work just a little bit faster. And some examples that I could think of were when you have to launch several jobs at once, and maybe vary a parameter or two, and especially if they're very similar jobs, that can be kind of tedious and error prone when you're using user interface. But if you're using Terrain, you can script that and make it much less error prone and more repeatable. Of course, there is a trade-off when you use a web API. You have to learn how to use it, and there is a pretty steep learning curve. When you want to launch a job using Terrain, you've got to authenticate to Terrain, identify an app that you want to run, and obtain some information about it. And then finally, you can launch the app and tell Terrain to send you a notification when the job is done. I mentioned the documentation earlier. There are two additional pieces of documentation. or these are the same links. I apologize for that. One thing I should mention is that if you're going to the older documentation, what you'll want to do is go to this endpoint index. There's a link here, and I will show you the documentation here momentarily. This is the Terrain interactive documentation. As you can see, it's got several categories of endpoints. I'm not going to go over this in too much detail just because of time constraints. But one thing that I would like to point out is this token endpoint. This endpoint is how you authenticate to Terrain. And there are some instructions here for authenticating to Terrain using this interactive user interface. And if you want to use this to interact with Terrain, you'll have to go through this step first, and then you can try out the other endpoints. The other documentation is this. I will mention that you'll want to ignore this authentication. This is an older style authentication that no longer applies. And when you go to the older documentation, you'll want to go to this endpoint index. And this is a list of all of the endpoints in Terrain and links to the documentation. Okay, now before we actually interact with Terrain, I should mention we're going to be using Python to interact with Terrain. I did intend to enter commands from the command line. I ran out of time. I can't cover all of the information that I want to cover and cover command line usage. If you would like, I can hang around for a little while after the presentation and answer questions about how to access Terrain using the command line, using mostly curl and JQ. So the first thing we need to do is import some libraries. We're going to be making extensive use of the requests library, which is a very good HTTP library in Python. And we'll also need to prompt for passwords, serialize and deserialize JSON, and pretty prints and data structures. Okay, so now that I've got the libraries loaded, we need to authenticate. Now the Terrain token endpoint uses HTTP basic authentication. So that means that we have to prompt for a username and password. And I'm going to do that now. This is where the get pass library comes in. And I'm using a different account because it's less likely that I'll mistype the password for this account. Okay, and then this is actually obtaining the token. So what this piece of code does is it uses the request library. We're going to be making an HTTP GET request. And we're going to send it to this URL and pass in the authentication using the username and password that we prompted for up here. This piece of code, or this line of code, checks the return status of the HTTP request. If the return status is anything, or if the return status indicates an error, it's going to raise an exception. So we'll get some nice red output here. And that didn't happen, so apparently I typed in the password correctly. Okay, and then this piece of code extracts the access token. If you would like to see what the response body looks like, it looks like, well, this is all of the optional field. Normally it just contains the access token and expires in. So what we're doing is we're extracting the access token element out of the response body. And then I'm creating the authorization headers, which is authorization, bearer, and then the token. And for the first example, I'm going to launch a Vice analysis. Now, Vice is our interactive computing feature. And in order to do that, I'm going to be using an app called RStudio ChipQC 1.22. And to get information about that app, I'm going to use this endpoint, which is the Terrain Apps endpoint, and I'm going to search for that name, that app by name. And I'm including the full name so that I can be sure just to get one app in the response body. If I used just RStudio, then I would get multiple apps and I would have to filter the results for the app that I wanted. Okay, so this is the app description. This is the app listing. The pieces of information that we want out of this are the system ID. The system ID is the name of the system that manages the app. So there are two primary values currently. We've got DE, which consists of apps that are managed by and integrated in the discovery environment itself. And we have Agave, which consists of apps that are managed by the Tapas API, which is formerly known as Agave. I'll provide you with a link to the Tapas API later. The rest of this information is helpful, but it's not anything that we need right now. If you want to know what all of that means, you can go up to the apps endpoint in the interactive documentation. The one that we're calling is Get Terrain Apps. And you can see an example value of the response body here. And if you want definitions, click on the model link and you can find out definitions of what all of those response body elements mean. Okay. Now this bit of code just extracts the system ID and the app ID from the response body. And then we're going to be calling this endpoint, which is Terrain Apps System ID App ID. And this will give us more details about the app. The bit of information that we really want out of here is the list of parameters. So we have a parameter ID. We're going to need that in order to provide the value for that parameter. In this case, the parameter is just the input directory that we want to pass to the app. So I'm going to extract the parameter ID. And building the submission request body is a little bit complicated. It's not too bad, but you do have to know how things fit together. All of these items here are either items that are required or items that I want to highlight specifically. The required items are config, name, app ID, system ID, a debug flag, output directory, and notify, which is just a flag telling the DE whether or not you want to receive an email when the job is done. The config is where you specify the parameter values. Name is the name of the job. App ID is the app ID that we extracted above. System ID is the system ID that we extracted above. The debug flag isn't of much use unless you're debugging the discovery environment itself. Normally you can just set that to false. And the output directory is the directory where you want the output to go. By default, the DE will create a subdirectory of that directory that's unique to that job and put all of the outputs into that directory. The requirements array is optional, but I do want to highlight it because one thing that comes up frequently with Vice apps is you need to set the memory limit. The reason for this is because Vice apps are a little bit more difficult it's a little bit more difficult to gauge how much memory we need with Vice apps, because the amount of memory used often depends not only upon the input data, but upon what's being done in the app. So, and there's no way for us to predict that, so we allow you to specify it. Usually you find the right value by trial and error. There's not a better way to do it at this point. Sometimes the tool itself will provide you with information about how much memory it might use if you're doing specific tasks. Okay. And the next thing I want to do is build a request body. So what I'm doing here, make sure I extracted the parameter ID. I think I did. Yes, I did. Okay. So what this code is doing is building the request body. So this takes the config. We're passing in the parameter ID, which is just this path to the directory. This is public data, so you can access it and run the app yourself if you want. The name of the app of this job is going to be Terrain Automation Vice, and we're going to pass in the app ID and system ID that we extracted above. The output directory is just the default output directory that's used by the DE. You can specify any directory you want. And the memory limit, this particular application doesn't require a lot of memory, so I'm just going to ask for 4 gigabytes, which is 4 times 2 to the 30th bytes. Memory limit is specified in bytes, so I have to do the math here to calculate the value. Okay, now with that request body, what I can do is call this endpoint to send an HTTP post request to this terrain analyses endpoint, pass in the authentication headers and the request body, and check the response. And apparently I hit the wrong key. Let me try that again. Okay, there we go. Okay, so this ID here is the analysis ID. I should say that this is different from the analysis ID that you'll encounter when you're looking in the discovery environment. The reason is that we have 2 different execution systems. One execution system is TAPIS, the TAPIS API. The other execution system is the discovery environment itself, and they generate their own IDs. So this ID refers to the analysis. The other IDs actually refer to steps within the analysis that we might want to look at later. We normally refer to that as the analysis ID just to reduce confusion a little bit, but that's the distinction. And the next thing we want to do is actually get information about the analysis. So I'm going to call this terrain analyses endpoint and pass in a filter that's set to, that looks for an ID with the value that we extracted above. And that provides us with this. For this particular analysis, or for this particular app, the username and password is always RStudio1. And as you can see, there's the example data directory that I passed in when I was launching the job. And then I've got this R script that you can run to get some nice plots down here. I'm not going to do this. If you're curious about this particular app, reach to Jasia. I probably mispronounced her name. I apologize if I did. Did a webinar on this app in the spring, I think. And you're welcome to go look at that. It's a great webinar, and you can see all of the output from this app, as well as the preparation to get to running this app if you would like. For now, I'm just going to close that. Okay. And the second example that I wanted to go to was processing multiple files. And this one is admittedly a toy example. The reason I use it is because I'm not a bioinformatician. I'm a programmer, so I know how to use grep. And so I'm going to use that. And I'm going to be extracting the shebang line out of a bunch of files. So in this case, I need to obtain a list of files that I want to process. Now this is going to use the paged directory listing endpoint to get the list of files in a directory in the data store. And as you can see here, I've got a query parameters listing the path and the limit to the number of files. There's 127 files in here, so I just passed the limit of 500. You can detect whether or not you've gotten the entire list by looking at the response body. There's a total number and a count of the number of files that you've got. So what I'm going to do here is execute this call and get the list of files. Now, I don't really want to launch 127 jobs, so I'm just going to take the first 8. And I'm going to build a request body. In this case, the request body is the contents of what we call a path list file. So the path list file is just a list of paths that we can use to tell the DE to submit multiple jobs. And so this has actually created the path list within the data store. The next thing that we need to do is obtain the app details, and this is exactly the same as what we did earlier. The only difference is the app name, of course. And in this case, we have 3 parameters that we want to look at. We've got the input file, or no, I'm sorry, this is the text to match. This is the regular expression that we're going to pass to grep. And we've got the input file. This is the file that we're going to search. And we've got the output file name, and this parameter is required, so we have to specify it. So the output file name is just the name of the file that we want to store the output from grep in. The rest of the parameters are all optional. We're going to leave those as the default values. And this piece of code extracts the parameter IDs. Once we've got the parameter IDs, we go through the step of creating the request body. In this case, I'm looking for a shebang line. Now, technically speaking, I could add the caret here to match the beginning of the line, but I'm not going to do that. So I'm just going to pass in a regular expression that searches for a hash exclamation point slash. And then the input ID is the path to the path list file. Or the parameter, the input parameter is going to be the path to the path list file. And then the output is just going to be a file called shebang.txt. And once again, we've got the app name, the app ID, system ID, and the output directory. And I'm just going to execute this block. That's the request body. And now I'm going to submit those jobs. Now, listing analyses in a batch is just a little bit different because when you submit a batch job in the discovery environment, it creates one parent job that basically maintains the status of all of the child jobs. So in this case, what we want to do is list the children of that parent job. So instead of filtering for the ID, we're going to filter for the parent ID. And the value, once again, will be the analysis ID that we extracted above. And we'll pass in the usual authorization headers and query parameters. And you'll notice that we've got 0 analyses so far. So what this means is that none of these analyses, none of these batch jobs have actually started executing yet. If we wait for a little while, they will execute later. And I'm not going to make you all wait for that. So I'll just go to the next example. The last example is what's known as a parameter sweep. Now this is a case where you want to take a non-input parameter and pass in different values in order to experiment with those values and see what provides optimal results. In this case, I'm going to be changing the error rate parameter in an app that we're using. The default error rate is 0.01. I'm going to be using 0.02, 3, and 4 as well. And once again, we obtain the app information. This is exactly the same as we did before. And this time, you'll notice that we have multiple groups. Now, group doesn't really apply to API usage. What this is, what the group corresponds to is the accordion panels in the app launch screen in the discovery environment. This allows app integrators to group parameters into logical categories. So we're just going to extract the fields that we want. In this case, we've got, I need to scroll down to the correct one. So we've got two multi-file selector endpoints. I haven't mentioned the parameter type yet, but the parameter type is the type of parameter that we're using. In this case, we're using multi-file selector, which means that we can pass multiple files in for this one parameter. This means that instead of taking a single path, the parameter needs to have a list of paths. One thing I should mention is that the parameter types, the values for parameter types aren't well documented at this point. If you run into a question, feel free to let us know and we'll be happy to answer your questions. If you do run into a question, I can pull up the discovery environment. You can click this icon, this intercom icon in the lower right-hand corner of the discovery environment. And you can send us a message and we will take a look at the message and respond to your questions. These messages that are entered in the discovery environment do go directly to the discovery environment team, so any one of us will be able to answer your questions. And I've got to find my Jupyter Lab tab again. So we've got two input parameters that we need. We need this read 1 and read 2 because we're doing a paired read analysis. And then we also need the error rate, which is the parameter that we're going to vary. The rest of the parameters will have the default values. And in this case, rather than write the code to extract it, I just copied and pasted. And I did that because the parameter labels are long and easy to mistype. So I'm just going to set these. And in this case, since I'm going to be submitting multiple very similar jobs, I wrote a little function to actually submit the jobs for me. So this is creating the function. This is creating the request body and sending it to the Terrain Analyses endpoint. And we're passing in the list of files for the first read and the list of files for the second read, and also the error rate. When we call this function, we're going to be passing in the same input files with a different error rate. And this will take a few seconds. And all of these jobs have been submitted. And if you go into the discovery environment, you can see that the jobs have been submitted. As a matter of fact, I can show you the notifications here. And that's the end of the presentation. So if anybody has any questions, I'll be happy to answer them now.
Thanks, Sarah. There are definitely some questions. Let's see, has anyone created a slightly higher level library to build and compose the various pieces?
No, we haven't. That is something that we're planning on doing. I should mention that for a while there was something in there was part of the Agave suite of programs did interact with Terrain. I don't know how far that went, so there might be some lingering libraries out there.
Okay. There's a question, and I'm going to kind of parse it a bit, but somebody wants to know a little bit more about various APIs like the iCommands API and what that does, and what the Tapis and Vice APIs do.
Oh, okay. Vice doesn't have its own API. Vice actually goes through Terrain. The discovery environment makes all of its requests through Terrain. The TAPIS API is actually something that I meant to mention earlier and I completely missed it, so I apologize for that. There's a link up here somewhere. As a matter of fact, I'm going to clear all the output to make it easier to find. Yeah, I'll just pull it up. Okay, so it's tapis-projects.org. And you can find this Getting Started link. And that provides you with a nice quick start tutorial for TAPIS. And you're welcome to go to that and explore. And this is the API that Terrain actually uses to submit jobs to the high throughput computing resources at the Texas Advanced Computing Center. And I said high throughput, I meant high performance. I apologize for that. And the other that was mentioned was also not a separate API. I don't remember exactly what it was, but I remember thinking that it was not a separate API.
The iCommands one.
iCommands, yes. The iCommands use a web API, and specifically they are a sort of a application programming interface. They're usually, I've never actually considered them this way because they're not functions that are called, but they are commands that you can run on the command line to interact with the data store. Eric Lyons did a webinar last week on the iCommands, and that's a great introduction to them. So I would recommend going to check that out.
Okay, and somebody has a question about the Agave API docs. Can you share that? Agave is, and Sarah, correct me if I'm wrong, but Agave is the precursor or the old version of TAPIS. Is that correct?
Yes, that is correct. TAPIS has been renamed, or Agave has been renamed to TAPIS, and the two projects might have forked, but TAPIS is the version that we use now. We still call it Agave in our system because we just haven't changed our code yet. I do have a link here in the Jupyter Notebook right here that goes to the TAPIS project.
Okay. And we can provide some of these links, these key links to these different APIs on our webinar page when we update it with the video recording. Let's see, one more question. Is there a recommended web API for accessing/writing to CyVerse data store? I have hacked using WebDAV commands using request library, but I'm curious if there is something else.
There are. As a matter of fact, you can use Terrain for that. We have a set of endpoints in here called Terrain File System, and these provide things such as directory listings, checking to see whether or not a file exists, and so on. And there's these file IO endpoints, which allow you to upload and download files to the data store. And you can also use the iCommands for it, but you have to shell out in order to do that. One other application programming interface that's available if you're using Java is Jargon, and that provides a useful way to interact with the data stores and other RODS instances as well.
Okay, do we have any final questions for Sarah while we've got her online? If not, thanks, Sarah. That was great. I'm sure people will be accessing that API and hopefully doing some really creative things with it to make their lives easier. And thank you for doing the presentation. Thank you all for attending, and please join us in 2 weeks for our next webinar, which will be on text mining and image analytics, some of Orange's advanced add-ons that can help you analyze unstructured and high-dimensional data such as sequences, expressions, text, and images. This is a follow-up webinar to one we did earlier this spring by Dr. Francesca Vitali here at the U of A. So stay well, everyone, and hope to see you back here in 2 weeks. And everybody's thanking you, Sarah, in the chat. So appreciate it. All right. Bye, everybody.
Thanks. Bye, everyone.